Today we're going to talk about lines and linear equations. The most important thing to know about lines is slope-intercept form, which is y equals mx plus b, where m is your slope, so that's your constant rate of change between 2 points, and b is your y-intercept. That is where your line crosses the y-axis and where x equals 0, making the connection that where your line crosses the y-axis, no matter where it is, that's where x equals 0 is going to be extremely important on the SAT and the ACT. Anytime you are given 2 points, you can find the slope and you can write the line in slope-intercept form, which we will do on a later slide. In order to find slope, you do change in y over change in x, or y2 minus y1 over x2 minus x1. So we are going to practice finding slope on the first set of points here, and then move on from there. So we're going to do 5 minus 3, y2 minus y1, over x2 4 minus negative 2. And we are going to end up with 2 over 6, which is really 1/3. Something to note is that it really doesn't matter which set of points you call y2 and x2 and y1 and x1, you just have to make sure you stay consistent. So these two have to be from the same point, and these two have to be from the same point. So we found our slope to be 1/3. Parallel lines, which are two lines that never touch, like railroad tracks, have the same exact slope. Perpendicular lines, which are lines that cross at a 90-degree angle, have negative reciprocal slopes. What that means is that we negate the slope and flip it. So if a line has a slope of 2, the perpendicular line is -1/2. If a line has a slope of 1/4, we're going to flip that, get 4 over 1, and then negate it. The slope would be -4. So, using that point we found the slope for on the last slide, we are going to figure out how to write that full equation in slope-intercept form. And the way we're going to do that is we're going to pick one of these 2 points, which are both xy coordinate pairs, and you plug it in for x and y. We can rewrite this like 3 equals 1/3 times -2 plus b. We're going to get 3 equals -2/3 plus b. We add this over, and we're going to get 11/3 equals b. So the equation for this line is going to be y equals 1/3 x plus 11/3, where our slope is 1/3 and our y-intercept is 11/3. A lot of times on the SAT or ACT, they will give you linear equations that are not in slope-intercept form. They might look something like this. Before you can evaluate them for slope or y-intercept, or really any question most of the time, you need to get it into slope-intercept form. And the way you do that is just some simple algebraic manipulation in order to get y alone. So we're going to practice with this question. We know we want to get y alone, so the first thing we're going to do is move anything that doesn't have a y attached to it to the other side. So that's going to be adding this 3x over to the right side. I'm going to put the 3x first just because we know in slope-intercept form the x term comes first. And then the last step here is going to be divide away the 2 so that the y is completely isolated, and we're going to get 3 over 2x plus 5 over 2, which means our slope is 3/2 and our y-intercept is 5 over 2. Last thing we're going to talk about today is just some vocabulary to remember with lines. An undefined slope is a vertical line. A zero slope is a horizontal line. A direct relationship would be a positive slope. So as your x-axis, the variable on your x-axis increases, so does your variable on the y-axis. They increase together and decrease together. An indirect relationship is a line with a negative slope. So as one is increasing, the other is decreasing, and vice versa. Parallel lines, remember, lines that never touch, they have the same slope. And perpendicular lines, 2 lines that intersect at 90 degrees, have negative reciprocal slopes. That is it for today's video. Happy skill building on Smarty Prep.